So hi, today the main topic is the scheduler. Um, what is scheduler and what is scheduling algorithm in computer science? So scheduling thing is actually used in operating system, and to understand those kind of things, you have to understand what is the program and what is the process, those kind of things. Um, so what is program? What I believe of the program is that the program is just a list of the instructions, and it's just list of instructions. There's a bunch of line of it. Instructions one, instruction two, and those kind of things. And if you have experience of using those like the really low program language, which is assembly, you will learn that there is no thing of like a process thing and those kind of thing. If you use just assembly, like example x86 based ISA, um, the CPU, our processor, just reads this instruction by per time. There's no like computer can read and execute these instructions just in the moment. It just cannot. It just reads line by line and it's just executed. And when you're trying to write some kind of bunch of instructions, for example, you have like 100 instructions. Your instructions, and since the computer cannot execute this entire instruction by one time, it has to store in the memory. So since now your next instructions has to be fetched in the memory, and when you're able to fetch this memory and fetch this instruction from the memory, it puts on the computer and it decoded and it executed. So after when you're trying to go to the next instruction to fetch, you just increase the PC, which is the program counter, and after that you're able to execute all the instructions. And but those kind of thing, those kind of like active flow, what I believe is also called in the operating is also called the process. When the program is running, that's called the process. So process means that the running instance of the instance of the program. But it's not only that. If you look at the process model, the process split into resource grouping, and execution. Oh, so what do I mean by that? The process, what we know as process, isn't really some kind of what to say it's not really big or some kind, or it's not really word of it. It's not just the magic. It's just the code. It's just the object that we just already defined, and it can have some kind of resources because operating system can send some kind of resources. Because example, your process can have some kind of like 3 megabyte or more of it. The operating system sends some kind of resource to it. And no moreover, it has stack or heap and those kind of data structure or PCB process control block. But whatever it has is doing resource grouping, and next thing is execution. The thread is doing execution, so which also means that the process has at least one thread. Those kind of things. So recap: the program is just the list of instructions, and when the program is running, and which means that it's called a process. When the program is running, it's just a process. So process means that you're running instance of the program. And why do we need scheduler. Why we need to have a scheduler? If your computer is really fast, you don't need some kind of scheduling. But um, there's a limitation of increasing our processor or hardware specification, and to some kind of handle this kind of issue, we also increase the software rather rely on the hardware specification, and also the scheduler also manage the process thing. And we and also it has it doing some kind of synchronization of it, but let me just skip this and let's discuss about those kind of really fascinating thing. Concurrency. Using this scheduler, we now able to say that we can just run the program concurrently. We can just run things concurrently. But what do you mean concurrently? In this world, in the real world, not the computer science world, is there concurrency of it? Example, you watch the F1 race car, the car race, and two fancy car almost went to this end line same time. So is this meaning concurrent? So what do you mean concurrent? So what is the meaning of the concurrent? Even though they seems like they go through this end line same time, but if you look at the milliseconds of it, or if you look at the precisely, there should be difference of it. So in the real world, there's no concurrency. It just seems like concurrency because we just define it as a concurrency because we think in our eye it just seems like doing at the same time, but it's not. But the concurrency, the perfect concurrency is perfect concurrency is in the comprehensive word in our computer? No, it's there not, because it doesn't break our real world. So in terms of that, our scheduler, our CPU seems like running some kind of like a program thing concurrently, but actually the scheduler is doing it. Scheduler is really fast that handles those kind of process state, which is ready. I forgot the state. It was like ready or just like running and terminate, whatever stuff, and it's doing really fast that it seems like concurrently. It seems like there's something concurrent thing. But the thing is that this could happen is because our scheduler is very efficient. But what if it is not? So let me try to elaborate more about scheduler algorithm, those kind of things. I think the basic scheduler algorithm is there's a three of it, which is FCFS and SJF and round robin. The FCFS means that first come, first serve. Example, you have process 1, process 2, process 3, process 4. Rather than you think about the how many burst time it has, the burst time means that how many the time it took the CPU runs the process. If the P1 burst time is like 5 seconds, let's say Rear doesn't make it really big, 5 seconds, but 3 or 4 seconds, 4 2 seconds. The FCFS means that it doesn't care about how many burst time it has. It just label into one queue of it. So it's a queue of it. P1, P2, P3, P4. You just label down based on the first come and first serve. This is like queue data structure. But next thing is SJF, shortest job first. Based on the burst time, it prioritizes based on the burst time. So I think, yeah, sure, this job first. So based on the burst time, so the P4 has the least burst time, right? So it has to be labor in the first, and next is P3, and next is P2, and next is P1. I think it's gonna be used some kind of mean heap or some kind of priority queue, but whatever. So SJF, those kind of thing. But round robin is really kind of, it's kind of fascinating, because what the round robin thing do is, okay, we just know that there was a problem on FCFS SJF. Example, the FCFS, if the process, the burst time is like 10 seconds, but this P2 is 1 second. When P2 it is at of the end, it has to wait for the P1 end, so which is may lead to the starvation of it. And SJF, what I believe of SJF is there's no priority, and there's no, yeah, there's no priority. I think SJF, but I think there's more problem. I forgot it. But round robin saw this FCFS problem and those kind of thing, and it's just making that, like Solomon King, what they did, it just slice it. 5 seconds, 3 seconds, and 4 seconds, 2 seconds, right? It just slices that the time of it, so that there's more slice the process, the sub process, and there's more. And but the thing is that it has the same amount of the time. It's just like really like Solomon King did. The king did, like, it just slice equally, so that no one trying, and every process can have same time for their burst time. But the problem is that there's some kind of issue when the real time scheduling needs. Example, if there's a real time, it has to be the order has to be really predefined rather than like slicing it like this. So the problem of the round robin is there's no priority of it. There's no prioritize the process. So it could be some kind of real time issue of it. So I think this kind of really basic scheduler that we just talk about. Round robin, SCFS. And also, I think this kind of round robin thing is, it already defined as a code in the C. I think you can look at the internet and watch the round robin, and how do I make a round robin using C, and how do I make a round robin using assembly code. So I think this is it. And I'm kind of really bad at explaining those kind of things, because I just learned operating system like 1 month, 2 months ago. So I'm not that good, but I'm trying my best. So this is it. Have a nice day. See you next time. Bye bye.